Section 2.4, Surveys and Cartesian Products. A group of students is asked to compare animated feature films. 34 like Up, 29 like The Princess and the Frog, 26 like The Fantastic Mr. Fox, 16 like Up and Princess, 12 like Up and Mr. Fox, 10 like Princess and Mr. Fox, 4 like all three films, 5 like none of these films. Since we're talking about 3 different films, we can make 3 circles for our Venn diagram overlapping. And we're going to label our circles Up, Mr. Fox, and Princess. Starting at the bottom of our list, 5 like none of the films. So we are going to have a 5 out here in our universe outside our films. 4 like all 3 films. So here, where all 3 intersect, we're going to put a 4. 10 like The Princess and Mr. Fox. So if we look at this intersection here of The Princess and the Frog and Mr. Fox, we already have 4. We need to have another 6 to add up to 10. 12 like Up and Mr. Fox. It's this section here. We already have 4. We need another 8. 16 like Up and The Princess and the Frog. We already have 4. We need 12 more to get to 16. 26 like The Fantastic Mr. Fox. That is 8, 4, and 6, which is 18. We need another 8 for just The Fantastic Mr. Fox. 29 like The Princess and the Frog. We've already included 12, 4, and 6. We need another 7 for The Princess and the Frog. 34 like Up. We have already included 24, so we need 10 more for Up. How many students like only The Fantastic Mr. Fox? There are 8 that are only in the Fantastic Mr. Fox section. How many students like 2 of the 3 films? That would be 12, 8, and 6, 26. How many students were surveyed? Adding up all the numbers, 60 students were surveyed. Scott, who leads a group of software engineers who investigate illegal activity on social networking sites, compiled the following information. T is the set of group members on Twitter. F is the set of group members following patterns on Facebook. L is the set of group members following patterns on LinkedIn. We need to answer the question, how many engineers are there in Scott's group? There are 3 sections we're talking about here: Twitter, Facebook, and LinkedIn. And now looking at the information we're given here on the side, the number of engineers that are not in Twitter, Facebook, or LinkedIn is 3. Not in any of those, so it's going out here in the universe. The intersection of Twitter, Facebook, and LinkedIn is 5. Right here in the middle, we're going to put a 5. Intersection of Facebook and LinkedIn is 10. We already have 5, so we need another 5. Intersection of Twitter and Facebook is 9. We already have 5, so we need 4. Intersection of Twitter and LinkedIn is 6. We already have 5. We need 1 more. Facebook only, 16. We already have 5, 5, and 4, so there should be 2. LinkedIn is 13. We already have 5, 5, and 1. There are 2. And Twitter, we already have 4, 5, and 1. We need to add up to 13. There are 3. If we add up the numbers in our Venn diagram, it will tell us how many engineers there are in Scott's group. And there are 25. Melanie, the officer in charge of the cafeteria on a military base, wanted to know if the beverage enlisted men and women preferred with lunch depended on their ages. On this particular day, Melanie compiled her data in the following table. She broke it down into age groups, Y, M, O, young, middle age, old, and the different drink types are cola, iced tea, and sweet tea. We have totals to the right and totals across the bottom. We need to find the cardinality of the following sets. The intersection of young and cola. If we look here at the young section in cola, our cardinality is 45. The number of people not considered old and unioned with the iced tea lovers. Not old would be 45, 20, 10, 25, 35, and 30. Unioned with all the iced tea. We already counted the 10 and 25. We need to count this 30. Our cardinality is 195 people. Cartesian products of sets. An ordered pair consists of two components, a first component, and a second component. The notation, ordered pairs are written in parentheses, A, B. The left-hand entry in the ordered pair is called the first component. The right-hand entry in the ordered pair is called the second component. We have two ordered pairs are equal, AB equals CD, if and only if A equals C and B equals D. True or false? 3, 4 equals 5 minus 2, 1 plus 3. 5 minus 2 is 3, 1 plus 3 is 4, so it's true. 3, 4 equals 3, 4. 3, 4 does not equal 4, 3. It is false. These are sets. Notice they are written as braces. They are not ordered pairs in parentheses. So in sets, the order does not matter. Those sets are equal, so that statement is false. 7, 4 equals 4, 7. They are ordered pairs. 7 does not equal 4, and 4 does not equal 7. It is false. The Cartesian product of sets A and B is pairing each element of set A with each element of set B. They are written as ordered pairs. The notation, A cross B equals the set of ordered pairs AB, such that A is an element of set A and B is an element of set B. The cardinal number of a Cartesian product. If the number of elements in set A equals A, and the number of elements in set B equals B, then the number of elements in A cross B equals AB times B, which equals BA. Example, we're going to let A equal 159 and B equal 6, 7. A cross B. Remember, we're going to write them as ordered pairs. Each element of A matches up with each element of B. Our ordered pairs, 1, 6, 1, 7, 5, 6, 5, 7, 9, 6, 9, 7. Find A cross B. There are 3 elements in set A, 2 elements in set B. 3 times 2 is 6. B cross A. Order matters. 6 1, 6 5, 6 9, 7 1, 7 5, and 7 9. The number of elements in B cross A. There are 2 elements in B, 3 elements in A. 2 times 3 is 6. A cross A. We could just write the second set A twice. 1 1, 1 5, 1 9, 5 1, 5 5, 5 9, 9 1, 9 5, 9 9. The cardinality of A cross A. There are 3 elements in A and 3 elements in A. A times A equals 9. 3 times 3 equals 9.